Hello, we're going to start section 1.5, day 2 on vertical and horizontal dilations. When we look at our original function f of x and we multiply it by a, we're going to produce a new function g of x. And we're looking at what does that factor a actually do to our function f of x? Well, there's a couple of different things that can happen. If a is greater than 1, it expands it vertically by putting out values that are going to be larger. And so those larger values at each point will actually make the graph narrower. So our g of x will actually be narrower. If a is between 0 and 1, it compresses vertically, which means it's going to widen. So we have our axes, and if we look at our f of x again, g of x, because the values are less on the y, will actually cause it to widen. Now, if we change and put that factor on the inside, so we have g of x equals f of a times x, then if we have a is greater than 1, it's going to compress it horizontally. It's going to do the opposite. And if 0 less than a less than 1, it expands horizontally. Which this is a narrows, and this will create a widens. Okay. And we're going to look at a few. Okay. Graph g of x equals a negative 0.2 of x quantity squared. Well, f of x being x squared would look like our normal quadratic. So g of x having a 0.2, which means it's between 0 and 1, means we're going to get a wider graph, and the negative on the outside means it's going to be reflected over the x-axis. So we're going to get a wider value of g of x. Okay? Let's look at a second one. F of x is equal to 3x squared if x is less than -1, -1 if between -1 and 4, and x minus 5 cubed plus 2 if x is greater than or equal to 4. Okay, so we've got our pieces. For our graph, we've basically got -1 and a +4. Okay, the easiest part is the middle piece. So that at a -1, between -1 and 4, including the -1. So including the -1 means we got a solid dot here, goes across to the 4 where it's open. Okay, that's the easiest piece to graph. Then for the other two pieces, you're going to have a quadratic 3x squared on the left. If we put a -1 in here, that's going to become 1 times 3 is 3. So that's going to start up here at 3. And it's going to be a quadratic going backwards. The other is a cubic function, and the easiest way of doing that is, of course, going to be to graph it. But 4 minus 5 is a -1 cubed. That's -1 plus 2 means a +1. It's going to start here at +1, and the graph is actually going to look like that. But to find that piece, it would be easiest to go on a graphic calculator or Desmos and piece that out. Okay? As we move on, a couple last little topics to talk about. First one is transformations with absolute values. Okay, so if we have a graph, this graph's going to be f of x. What happens if we want to look at that same graph? But now it's going to be g of x equal to the absolute value of f of x. So in this case, the absolute value is just going to make everything positive. So we have positive values coming out, and when it dips negative, that piece that's below the axis is going to be flipped or reflected above the axis. So it'll be reflected above. So our graph, same graph until we get to boom. At that point, now the points are just reflected up until we get to the next point, and then it'll go back to our original graph. Now, that's over the x-axis because we were looking at the absolute value of the whole function. What happens if we only look at the absolute value of the x inside the function? So what happens when g of x is equal to f of the absolute value of x? Well, let's graph a f of x. So if f of x is going to look like this, if our inputs, though, are all going to be positive, then the minute we switch to the negative side, it's going to look like the positive side on the x instead of the y. So instead of it reflecting up over the x-axis, we're going to reflect the positive across the y-axis. And so we're going to end up with our original positive side for g of x, but the negative side is just going to be a reflection because your input values are the same as they were over here. So in this case, it's reflected across the y-axis. And replacing the left side. Okay? That's the last piece of section 1.5 on vertical and horizontal dilations and some absolute value transformations. Okay? I'll see you next time.